What's up, scholars? Today we are starting our Chapter 12 crash course into surface areas and volumes. So we got a lot of formulas coming at you. So first let's talk about what we might be finding surface areas and volumes of. Polyhedron. It's a solid that's bounded by polygons, many polygons, and encloses a single region of space. Here's an example of a polyhedron. Some other terms, we have an edge. That E got cut off. Edge is a line segment formed by the intersection of two faces. So if here's a face, and here's another face, those are our flat surfaces right there. That would be an edge. Now we have a vertex, a point where three or more edges meet. So here again was a face. Here was another face. Here's a third face. And they all intersect right there at that vertex. Pretty cool, huh? Oh, yeah. Alright, so let's name some of these guys and to figure out which ones are polyhedra. Again, polyhedra are going to be bounded by polygons. So we're going to be looking for polygons in these shapes. This first one looks like a can of soup. That's called a cylinder. Is that a polyhedron? Well, no, because this face is not actually made of a polygon. That's not a flat surface. That's a rounded surface. This here, this boxy looking thing, that's called a prism. And that is a polyhedron. All of its faces are polygons. This ball dude is a sphere, and for the same reason that the cylinder was not a polyhedron, this one isn't either. No curved spaces allowed. This is a special kind of prism where all the sides are equal. That's a cube. And if a prism was a polyhedron, so was a cube. This right here looks like an ice cream cone upside down. It's called a cone. We got some curved surfaces, not a polyhedron. And this one, this pretty beautiful thing, is called a pyramid. And it is a polyhedron. Cool, cool, cool. All right. So if we wanted to find the surface area, we'd be finding the sum of the areas of all the object's faces. We're going to use different formulas to find the surface area depending on the number of bases. You will not have to memorize these formulas. You will have to know how to use them. So when we have two bases, like prisms or cubes, again that's a special type of prism, or a cylinder, we can still find the area or surface area of this thing even if it's not a polyhedron. When we have two bases, meaning two flat sides that are the exact same shape, two flat sides that are the exact same shape, our general formula for surface area is 2 times the area of the base plus the perimeter times the height. So again, B stands for area of base, and P stands for perimeter of, that's an R, perimeter of base times the height. So again, we can use this for square prisms, triangular prisms, and cylinders. The bases of these dudes are the names of the prisms. So that's a square prism, meaning the base is a square. And it's got two of those bases. Triangular prism has a base that is a triangle. And it's got two of those. A cylinder has a base that's a circle. And it's got two of those. So let's do an example here. Let's move my paper up. Yeah, here we go. First we got to figure out what this is. Well, that said that's 7 yards, which I know has to be the same as the top here. That's also 7 yards. This is 7 yards, that's 7 yards. So it looks like every single side of the base is 7 yards. So this is a square prism. The height is 5. Square prism. B is the area of the base. Okay, area of the base, area of a square, length times the width. Since it's the same number, it's side squared. So our area of the base is 7 times 7, which is 49 yards squared. The perimeter of the base, add up all the sides, 7 plus 7 plus 7 plus 7, or 7 times 4, is 28 yards. And then our surface area was 2 times the area of the base plus the perimeter times the height. So that's going to be 2 times 49 plus perimeter, 28 times the height, equals, I'll leave that as exercise to the reader. Figure out the answer to that. Number 2, what's the shape of our base here? It is a triangle. There are 2 triangles. So this is a triangular prism. Great. B is area of the base. Area of the triangle here is 1/2. The base of this triangle is 8 kilometers. Height of this triangle is 6 kilometers. 1/2 times 8 times 6. Half of 8 is 4, times 6 is 24 kilometers squared. Perimeter of the base, that's 8 units long, that's 6. That 10 is the same as this 10. So perimeter, 8 plus 6 plus 10. 8 plus 6 is 14, plus 10 is 24 kilometers. And then surface area, again, is going to be 2 times the area of the base, which is 24, plus the perimeter, which is 24, times the height, which is 4. And again, you can solve that one and get you some points for it. All right. A cylinder is kind of a special case of that last formula, where the surface area is still 2 times the area of the base plus the perimeter times the height. But the perimeter of a circle is what? It's called their circumference. So this is 2b plus c times h, where that is circumference. And what's circumference? 2 pi r. So in our example here, 2 times our area of the base. What's the area of a base in a circle going to be? Area of a circle is pi r squared. So S would be area of the base, 2 times area of the base, pi times r squared. R is 4. Pi times 4 squared plus C is our perimeter, so 2 pi times 4 is our radius, and h is still our height, which is 7. Okay, you're going to finish that, and that sucker. Doing great. Okay, if we have only one base, we don't have a prism anymore, we have a pyramid. So our pyramid has a different formula. Our surface area is going to be, again, the area of the base plus 1/2 the perimeter of the base times L, which is our slant height. Slant height is the length of this segment here that goes along one of the faces. So B is still area of the base. P is still the perimeter of the base. But L now is the slant height. Slant height. So not to be confused with the actual height of this thing. It's not the length from the base to the top. It's not how tall this is. The slant height is the height of the triangle, one of the triangles of the faces. Okay. So this one here, we look at what the base is to try to figure out what the names are. The base of this prism is a square, I can tell, because all those are right angles, and two of these sides are equal, which is going to mean the other two sides are equal. It's the only way that's going to work. So this is a square pyramid. And this one over here, what's its base? It's a triangle. So this is a triangular pyramid. Okay, you're going to find the area of that base, the perimeter of that base, and the surface area for both of these. A lot of legwork for you guys on this one. A lot of calculations. But the only way we get better is if we practice. So I'm giving it to you. We got a special case of our pyramids, which would be a cone, because its base is now a circle. So our surface area is still P plus 1/2 PL. However, area of our base now is area of a circle, which is pi r squared. And, oops, that's supposed to be a plus. Plus 1/2. The perimeter now is the perimeter of a circle, which is the circumference, which is, I'm just making errors all over the place. 2 pi r, L is still the slant height. So let's rewrite this. Pi r squared plus 1/2 times 2 times pi times r times L, the slant height. Well, what's 1/2 times 2? That's just 1. So let's get rid of that. Pi r L is the slant height. Okay. Also going to let you guys do this one. Look at me. Letting you do all the things. Again, you're using the slant height, not the height of the cone. It's the length of the side here. So your slant height in 8 is 30. Slant height in 9 is 23.4. Be careful. Try to be tricky. Giving you diameter. Watch out. Ooh, ooh, ooh. All right, that was surface area. Let's move on to volume real quick here. Volume of a prism or a cylinder, again, that's something that has two bases. That's going to be the area of the base times the height. Area of the base times the height. Volume of a pyramid or a cone is going to be 1/3 the base times the height. Only thing we got to be careful with is our base a polygon or is our base a circle? Okay. You're going to do the thing. You're going to practice your formulas. I will help you with this guy setting it up. Because what kind of thing is this? It's a right prism, really meaning a right triangle. So our base is a right triangle. So the area of our base is 1/2 the base of this triangle, 5 times 12. So I'm going to do half of 12, which is 6, times 5, which is 30 millimeters. Lots of bumps there. Squared. Okay. Finish that one, finish that one. You're doing awesome. I want to get to this last one here, which is a little bit different. Find the volume of this right hexagonal prism. So this is the base we haven't talked about yet. A base of a hexagon. The area of this base, our B here, is going to be 1/2 times A, which is our apotheum, times S, times N. So S is going to be the side length, times N is the number of sides. So we're still going to use the volume formula. B equals BH, but now A is our apotheum, which is the distance from the center to the outside face where it would make a right angle. So in this case, A would be 6.